Lesson: Bias and Fairness in AI, Identifying and Mitigating Risks. Bias and fairness in artificial intelligence are critical considerations that underpin the ethical deployment of AI technologies. These issues are not merely theoretical, they have tangible impacts on decision-making processes in sectors such as healthcare, finance, and criminal justice. Bias in AI can arise from various sources, including data that reflects existing societal prejudices, algorithmic design, and implementation contexts. Fairness, on the other hand, involves ensuring that AI systems operate without favoring certain groups over others, promoting equitable outcomes. Addressing these challenges requires actionable insights and the implementation of practical tools and frameworks. Understanding bias in AI begins with recognizing its origins. One primary source is biased data, which often mirrors historical and societal inequalities. For instance, an AI system trained on historical hiring data might perpetuate gender or racial biases if those biases were present in the original dataset. In a study by Buolamwini and Gebru, commercial facial recognition systems were found to have higher error rates for women and people of color, demonstrating how biased data can lead to discriminatory outcomes. To mitigate such risks, it is crucial to employ data auditing tools that can identify and rectify biases within datasets. Tools like the AI Fairness 360 Toolkit, developed by IBM, offer a comprehensive suite of metrics to assess and mitigate bias in data and models, providing an actionable framework for professionals to enhance the fairness of AI systems. Algorithmic bias is another significant concern, arising when the design or implementation of AI algorithms inadvertently embeds biased assumptions. Ensuring fairness in algorithms requires meticulous attention to how they are constructed and validated. One effective strategy is the use of fairness-aware machine learning techniques, which aim to incorporate fairness constraints directly into the model training process. For example, adversarial debiasing is a technique where a model is trained to predict outcomes while simultaneously minimizing an adversarial network's ability to determine sensitive attributes like race or gender. This method helps to ensure that the trained model does not rely on biased features, promoting fairer outcomes. Practical frameworks for assessing and ensuring fairness in AI systems are essential for professionals. One such framework is the Fairness, Accountability, and Transparency in Machine Learning Principles. These principles advocate for transparency in AI decision-making processes, accountability for outcomes, and fairness in treatment across different demographic groups. Implementing these principles involves conducting thorough impact assessments of AI systems, engaging with stakeholders to understand potential biases, and continuously monitoring AI systems for fairness post-deployment. Case studies provide concrete examples of how organizations have successfully implemented strategies to mitigate bias and enhance fairness. In the healthcare sector, machine learning models have been used to predict patient outcomes and allocate resources. However, biases in these models can lead to unequal treatment across different patient groups. A notable case involved an AI system used to prioritize patients for high-risk care management programs. The system was initially biased against Black patients due to its reliance on healthcare cost data, which did not accurately reflect health needs. By adjusting the model to prioritize clinical data over cost data, the system's fairness improved, leading to more equitable patient outcomes. Another sector where bias and fairness in AI are critically important is criminal justice. Predictive policing algorithms, which aim to forecast criminal activity and allocate police resources, have been criticized for perpetuating systemic biases. These algorithms often rely on historical crime data, which can reflect and reinforce existing prejudices against minority communities. To address these issues, organizations have implemented fairness auditing tools such as fairness indicators, which provide metrics to assess bias in machine learning models. These tools enable practitioners to identify disparities in model predictions and take corrective actions to ensure fairer outcomes. Beyond technical solutions, addressing bias and fairness in AI also requires a cultural and organizational shift towards ethical AI practices. This involves fostering a diverse and inclusive environment in AI development teams, as diverse teams are more likely to recognize and mitigate biases. Moreover, organizations should establish clear ethical guidelines and accountability structures for AI development and deployment. Ethical frameworks, such as the AI Ethics Guidelines drafted by the European Commission's high-level expert group on AI, provide valuable guidance for organizations aiming to develop responsible AI systems. In addition to internal organizational efforts, collaboration with external stakeholders is critical. Engaging with affected communities, policymakers, and interdisciplinary experts can provide valuable perspectives that inform the development of fair and unbiased AI systems. Such collaborations can lead to the co-creation of AI solutions that are more attuned to the needs and concerns of diverse groups, ultimately promoting fairness and inclusivity. In conclusion, bias and fairness in AI are complex but essential considerations for the ethical deployment of AI technologies. Professionals can mitigate risks by employing practical tools and frameworks such as AI Fairness 360, adversarial debiasing, and FAT-ML principles. Case studies from healthcare and criminal justice illustrate the real-world impact of these strategies and highlight the importance of ongoing monitoring and assessment. Furthermore, fostering a culture of ethical AI practices and engaging with diverse stakeholders are crucial steps towards achieving fairness in AI systems. By implementing these actionable insights, professionals can contribute to the development of AI technologies that are not only powerful, but also equitable and just.